Hello and welcome to Podcast.init, the podcast about Python and the people who make it great. I would like to thank everyone who supports us on Patreon. Your contributions help to make the show sustainable. When you're ready to launch your next project, you'll need somewhere to deploy it, so you should check out Linode at www.podcastinit.com/Linode and get a $20 credit to try out their fast and reliable Linux virtual servers for running your app or experimenting with something that you hear about on the show. You can visit the site at www.podcastinit.com to subscribe to the show, sign up for the newsletter, read the show notes, and get in touch. To help other people find the show, please leave a review on iTunes or Google Play Music, tell your friends and coworkers, and share it on social media. You can also now get a t-shirt and help support the show by going to teespring.com/podcastinit. You can also pick up a mug and a sweatshirt while you're at it. Your host as usual is Tobias Macy, and today I'm interviewing Guillaume Valadon about Scapy, the Swiss Army knife for packet manipulation in Python. So Guillaume, could you please introduce yourself?
Yeah, so hello everyone. So my name is Guillaume. I'm French and I've been maintaining Scapy since a few years by now. During my, let's say, day life, I'm doing network security. And me and my team, we use a lot Scapy to play around with the network and implement new protocols.
And do you remember how you first got introduced to Python?
The first time was, I think, in 2003 during a conference, and someone was presenting the language. And I think my first thing I said about Python, was to that I didn't like the way they were enforcing the way you have to code. I didn't like at that time the fact that you don't have to put brackets, for example, and you need to indent your code. Indeed, like let's say 15 years after that, that's what I like with Python, the way that the language is forcing you to indent your code and making your life easier, and also making your code easier to read. And the first project I did with Python was indeed like playing around with Scapy. The first time was in 2004, I guess. And so it's a mix between Python and Scapy for me, at least. I started Python because of Scapy.
And can you explain what Scapy is and the problem that it was trying to solve when it was created?
So first of all, I'm just one of the Scapy maintainers, the other one being Pierre Lallet. And Scapy was designed and implemented by Philippe Biondi, another French guy, in 2003. And the main goal of Scapy is to ease people's life when it comes to playing with the network, which is sending packets to the network, receiving them, and also implementing new protocols. So Scapy is really good at helping you and people to easily and quickly implement a new protocol. For example, adding a new network protocol, adding a new packet header, it's just in between 10 or 15 lines of Scapy, which is really nice and simple. And Scapy helps you to do that. It provides you, let's say, enhanced Python shell, where you can send packets to the network, read them, and interact with packets. And also you can use Scapy as a regular Python module in order to build your own tools and build your tools on top of Scapy.
And if you do have a custom packet format, is it possible to provide a definition for that so that as you receive those packets, it can sort of unpack them as the packets arrive into your program?
Yeah, that's the way it goes. Indeed, in Scapy, what you need to do is to define an object. Let's call it, like, for example, layer 1. And you will also describe in Python the fields in your layer 1 packet. And most of the time, Scapy will do the job for you of reading the packet from binary into a Python object, and then taking your Python object and converting it to binary. And that's just a matter of defining a new class and defining a list of fields.
That would have been very handy in a project I was involved in a few years ago where we had a custom sensor and we had a custom packet definition where the different bit fields within the headers had different meanings. And so we needed to write some custom code to parse those out from the binary object and then figure out what those different fields were supposed to pertain to. So it seems that Scapy would have been able to solve that problem much more elegantly than the code that we ended up having to write.
That's a typical use case. And it's, of course, generic, so you can reuse your packet definition wherever you need. So the thing I really like about this project is you are not stuck with one, let's say, way of doing things. If you decide to implement your packet in order to decode it, later on you can also decide to inject it in the network. And that's what I really like. Only one definition, one piece of code, and you can do both, sending and receiving. And when it comes to playing with a protocol, for example, for security audit, or defining a new protocol for experiments, it's really, really powerful.
How has the decision to build Scapy in Python benefited the project? And are there any edge cases where Python starts to fall down in terms of the implementation?
I don't know why, indeed, Philippe started to use Python for Scapy. I guess that's mainly because the language is really flexible. It was easier to achieve this kind of tool with Python rather than C. But for this project, Python is really good because of its dynamic features. It allows us to benefit for the dynamic creation of objects, for example. Also, it's really simple with Python to have your own shell. So for us, Python is like, and Scapy on top of Python is like a domain-specific language. And that's really nice because we can enhance Python language with Scapy features. And another benefit for us is there's a lot of targets, meaning by that operating system or architectures for Python. And also today Python is everywhere. So it's really easy to have a tool that works on Windows, OS X, FreeBSD, OpenBSD, and so on. And that's, for me, I guess, the main benefit of Python. On the other hand, Python and the way Scapy is defined and developed makes Scapy slow in some situations. For example, if you want to inject a lot of packets really fast, or if you want to read a lot of packets from the network to sniff packets really, really fast too. And Scapy, because the way it's like building object on the fly and dynamically is, let's say, slow. However, slow is, you can still be able to inject at a rate of, let's say, 200 megabits per second, and you can also achieve the same speed while sniffing the network. So it's not really slow, but today we have like gigabits or 10 gigabits interface, so to that extent, Scapy is slow.
And would something like Python give you the opportunity to speed up the critical pieces to increase that overall throughput?
Not to my knowledge. We tried PyPy last year, for example, but we didn't manage to make it faster by switching the Python interpreter. And recently I tried a project from Facebook or Instagram, I forgot, but same stuff. There is not a big benefit of changing the Python interpreter.
And given the fact that you're dealing with network protocols, so mostly at the bits and bytes layer, what are some of the challenges posed by Python 3? I noticed that it is not yet supported, so I'm sure that dealing with the shift to how bytes and bits are handled in the newer version is likely going to pose a bit of an issue for you.
There's indeed some contributors trying to push, let's say, a compatibility layer into Scapy to achieve Python 2 and Python 3 compatibility. And that's kind of hard to do because the switch of the way bytes are handled in Python 3 makes it difficult to make this compatible version. But hopefully that's something they will manage to achieve in this year, in 2017. So that means like we need to change a lot of codes to have this compatibility layer. So one of the perspectives is to use the 6 Python module in order to abstract Python 2 specific stuff or Python 3 specific stuff. And on this topic, one important fact to keep in mind is that we try to stay Python 2.5, 2.6, and 2.7 compatible until late 2016, which means that we are not able to use, let's say, 2.7 and 3 compatible features, such as list comprehension and so on. So we had to deal with the backward compatibility of maintaining Python 2.5 compatibility. And that's something we try to keep as long as possible, as the use case here was, for example, you are doing a network audit on a really old, and you find a really old Linux laptop, and only has Python 2.5, and you want to use Scapy. So that's why we try to keep this compatibility for long, in order for people to be able to use Scapy, let's say, everywhere. But because the language, let's say, Python 2.5 language is so old, we decided to drop this backward compatibility.
And given that the project has been around for 10 years, I'm sure that that has also added some legacy weight to that backwards compatibility, as well as increasing the overall effort necessary to move forward to Python 3 when the time comes.
Yeah, but I think we won't move to Python 3 only. So we'll try to achieve some way to run both Python 2 and Python 3 on Scapy, or with Scapy. And yeah, we have like a lot of things we need to clean up. For example, we have a lot of map functions in Scapy, It's like more than 100, and we need to rewrite them using list comprehension. And that takes a lot of time. Of course, 223, the tool, help us to do that. But for some time, we need to fix, let's say, weird syntax ourselves. So it takes time to clean up the Scapy code and make it, let's say, more recent. Like removing the old 2.5 or 2.6 only part of the code, it takes time to remove that.
And how has the overall project evolved from the initial prototypes that were created by Philippe Biondi through to its current incarnation as Scapy 2?
I think a lot changed. Last year, we tried to do some archaeology with Philippe, and we found the first Scapy file, which was not called Scapy at the time. It was like Pirates. It was just a single file, and it was the first, let's say, piece of Scapy inside. And at that time, the tool only allows you to inject packets at layer 2. It was not able to read the packets, but still you can find in the file a syntax which is quite similar. And that was in November 2002, sorry. And then Philippe decided to start Scapy in 2003. And at first, again, it was a single file, and scapy.py. That's something you can just download on a laptop, on your server, and start using Scapy. It was really convenient, for example, for security audits, but the design was not perfect, and the site was like getting bigger and bigger. And the last release, which was a Scapy of the Scapy 1 branch, it was in 2008, and Philippe decided to split this scapy.py file into a Python module, and that was released in 2008. It was called Scapy 2. So the design is a bit different, and it's more similar to what you can expect from a regular Python module with directories and submodules and so on. And then, so it was a release of version 2 in 2008, and then the project evolved in between 2008 and 2011, and finally Philippe didn't have time to maintain the project, and not much did happen in between 2011 and 2014, sorry. So Philippe asked us, like, it was me, Pierre, another guy, Nicolas, to take over the code and try to maintain it. So we tried to do that, and the first, let's say, new release happened in 2014 with Scapy 2.3.0. It was mainly, at that time, fixing all bugs, merging, let's say, also all pull requests, which was like basic maintenance work. So the project evolved a lot since it's almost 15 years now. So a lot of things changed. For example, Philippe decided to do his own unit test, and the tool is called UT Scapy. And the main goal was to achieve what we do today with PyTest, for example, to have unit test of the code inside Scapy. But at that time, Philippe had to develop its own system. So also a big change compared to Scapy 1.
And I understand that in the process of that evolution, you were originally hosted on Bitbucket and then moved to GitHub. So I'm wondering what prompted that decision and how has that decision played out?
Oh, first, the move was, I think, the best decision someone in the project ever made. It was the other maintainer, Pierre, who decided to do that. And the first goal was to move from Mercurial to Git. It was not about GitHub at this time, but we both use Git a lot in our project, work-related or personal project. So we wanted to stop using Mercurial for Scapy. So that's what we did. And then we also decided to move to GitHub, and the goal was just to attract more people. There is indeed more people with GitHub accounts, people with Bitbucket accounts. So at first, it was the main idea was to move the project to GitHub to attract more issues, more contributors, and so on. And finally, what we got also more maintainers, more people helping out with the project. And we moved to GitHub in January 2016, and since then the project is, let's say, more active than it has ever been. So there's a lot of issues, a lot of pull requests. Also, really like the pull request system on GitHub because of specific features like the merge or the squash feature. And also there is a lot of services that we're using, like Travis for CI. So at first we use Travis to check for Linux and run unit test on Linux. Then we also added OS 10, and then we are also able to test Scapy on Linux, OS 10, with a regular user, with root, and so on. And later on, I think it was in November, we added support for AppVeyor, which is a unit test on Windows. And finally, in December, we had support to Code Cove, which is a website that displays your code coverage. And I think that was a smart move to move to GitHub, mainly because of these services. It's really simple to make your pull request trigger calls to these services and then launch tests. And indeed, Scapy code is getting better and better, the quality of the code and the stability, mainly because of this Travis and Abeyor websites.
And going back briefly to your mention of the multiple platform support, one thing that I meant to ask is whether you're aware of if Scapy is able to run on MicroPython for being able to be used in microcontrollers or embedded systems.
No, I never tried. At some point, we had some weird requests, for example, to make it work on, what was the name? Jython, the Java JVM-based Python, but I think it's not working. And last week we had a pull request to a project, I forgot, which is a Python interpreter on iOS. But this, the iOS-based one or the Java one, they are really specific because you miss a lot of, let's say, bits from the OS module, and Scapy relies on that a lot. So I don't know if it will also be the case with MicroPython. I will suspect that it won't work. I mean, the packet parsing part, maybe, packet building also, but injecting and receiving packets, I guess that they won't be able to work. For example, PyPy, last time I checked, 1 year ago, was not able to fully run Scapy. For example, you are not able to inject packets with the type IP row. So indeed, Scapy is not fully working on PyPy. You can't inject packet with PyPy. At least last time I checked 1 year ago, because his specific, let's call it syscall, even though it's not one, was not available on PyPy.
So who is the target audience for Scapy, and what are some of the primary intended use cases for it?
So the first target was people doing network security audits. And the main goal was to ease their life, help them to discover the network, send packets, record packets, and so on. Another aspect was to help people writing network-related exploits. So from time to time, you have an exploit against Windows or Linux, and you need to write a lot of C code in order to send your packets in a specific way. And Scapy helps you to write packet really easily and send your exploit, for example, if you need to in just one line of Python. These two kind of people were the primary targets. And nowadays, the target audience is more related to people willing to test or write new protocols. And for example, especially people wanting to do fast prototyping. So people that do not want to work with C or, for example, implement Wireshark dissector, they tend to use Scapy for fast prototyping. And finally, more and more people are using it to teach network protocols and the concepts, because it helps students to have a simple access to packets. For example, you can teach how traceroute works by making students write packets themselves, and also having a look at the answers.
So reading through the documentation, I was noticing that there's the ability to layer different types of packets in an arbitrary fashion. So I'm wondering, how is the project architected internally to allow for that level of flexibility and composability of the different network layers and network protocols?
Okay. So first we have the slash or divide operator that was redefined in order to be able to stack network layers on top of each other. And that's a single trick, but that's also make Scapy really special, because you just can stack with a divide, IP, and then UDP, and then DNS. So in one line, you can stack protocols. So the first thing in the design. Also, we have what Philippe called default values that work. So by using Python keyword arguments, we can decide to specify or not specify, for example, the IP destination address or source address or the TTL field, and Scapy will take care of everything for you. For example, if you don't specify the IP checksum, Scapy will compute it for you. On the other hand, if you want to put 0 for the checksum, Scapy will send an actual 0. If you try to do that with a regular library, most of the time, you won't be able to send a checksum of value 0, because the system will say, okay, if it's 0, I will compute the checksum. So that's another Scapy feature. Going back to the packets, internally, Scapy is designed around fields, and a field, it has a name and a default value. And by combining fields, you can make a packet, and then Scapy is able to, based on the types of the fields, is able to dissect the packet, so read it from the network, and also able to build the packet into raw bytes. Finally, Scapy by design is able to, let's say, dynamically encode and decode packets. Yeah, I think that's it.
Given the level of flexibility that the library enables, what are some of the most interesting or unexpected ways that you've seen it used?
That's a good question. So there's a lot of people playing with Scapy to do tools and proof of concept. For example, people trying to use Scapy to detect 802.11 access points, because Scapy can do that, can play with Wi-Fi. Last year, I discussed with OpenBSD people because they are using Scapy to test their IPv6 stack. So it was really nice to see that Scapy is used in OpenBSD to test their stack. Also, I'm aware that some people managing the root DNS servers are using Scapy to do some network testing to build specific packets in order to test their architecture. And finally, this one is kind of funny. I don't know if you know, but NSA got some code leaked last year from people called shadow brokers. And you have one exploit in there called extra bacon, and this one is using Scapy in order to send SNMP packets to some Cisco router in order to exploit them. So this one is kind of funny. Even NSA is using Scapy.
Well, it's a good validation of the work that you're doing on the project, if even the NSA is using it for their particular use cases.
No, it was kind of funny to find my name into the shadow brokers leak.
So given the wealth of protocols that are available at the network layer and the wide variety of them that are implemented and supported in Scapy, what have been the most problematic to implement and to maintain? And are there any protocols that you are not yet able to support?
Yeah, the one with playing with bits and not bytes, I think we'll never be able to support them. If they are not byte aligned. For example, if we have like 3 bits and 4 bits, and that's it, so it's not a byte, it's only 7 bits, that thing we won't be able to support this kind of protocols because the way Scapy is designed, unfortunately. I think in the past, one really difficult protocol to implement was SNMP because it's based on ASN1, and Philippe Biondi did an really amazing job at implementing ASN1 in Scapy. And this part of the code is kind of tricky, but works fine. And last year, one guy, Maxence, another French guy, rewrote the implementation of X509 certificate, the one used in HTTPS, using the native ASN1 Scapy support. So this part of the code again is, let's say, more difficult to maintain because of the way the protocol is designed. It's like a pure binary protocol. It's kind of difficult. On the other hand, you have like at Scapy another part which is also more difficult than the other. That's IPsec and TLS. So we got IPsec support 2 years ago, I think, and TLS last year. And this one are more difficult than the other because they deal with crypto. So we need to handle keys and so on. So they are way more difficult than Ethernet, for example. So that's the most difficult ones. And finally, we have like ones that are difficult, not because the protocol is difficult or the fields are weird, but just because they are an old implementation in Scapy. For example, DNS, the code is really old. It's not the best way to write a DNS protocol in Scapy. But again, due to some backward compatibility, we decided to keep it this way. And from time to time, like the DNS layer tend to break. But it's getting better.
And what have been some of the most challenging aspects of developing and maintaining Scapy overall?
So for me as a maintainer, I think the most challenging part is to keep the core working. So for me, it's really easy to write a new protocol in Scapy and to maintain it, but the core is still from time to time buggy, and because we try to support a lot of operating system, so again, Linux, Windows, OpenBSD, NetBSD, FreeBSD, OS X, Solaris, it's really could be difficult to adapt to some specific usage or specificity. So from time to time, we have bugs in the core that are really difficult to reproduce and to fix. So for me as a maintainer, that's the most challenging part, like keeping the core working on different operating system. And things like Travis and Aveyor, they'll help us a lot to make sure that what we make, the change we make, they don't break anything. That's really, really nice. Also, it was a bit silly, but we used to support Python 2.5, 2.6, 2.7, and PyPy. And that was a bit challenging because we couldn't use, like, let's say, modern Python features. So that's something we stopped last year, and as of today, we only support 2.7.
Yeah, I'm sure that will allow you to go through and clean up a lot of the old code and refactor a lot of things to make them easier to reason about and work on going forward.
That's one aspect of what we want to do here. That's still difficult because we also want to keep Git history. We don't want to break it. So from time to time, it's also difficult to, let's say, maintain historical comments or reason and move the code to, let's say, a newer world.
So what do you have planned for the future of Scapy?
Let's say a lot of things, but if we have a look at 2016, which is not the future but recent past, we did a lot already. We have a better Windows support that works fine. We have a native BSD support, so we have no dependency. You can just git clone Scapy. It will work on OS 10, for example. So it was nice. And due to this new feature, we have a decrease in the number of issues related to OS 10. People do not need to install Python dependencies anymore related to libdnet and libpcap, which is nicer for us. Also, we got a really nice TLS and X509 support, as well as HTTP2. So that was for 2016. And why it's interesting to have that in mind, that's mainly the Windows support, TLS and HTTP2. It was done by new maintainers. So because we switched to GitHub, a lot of people are coming to a project and pushing new pull requests. So I don't know what people will push in 2017, but on our side, maintainers, what we want to do is to write more unit tests in order to fix some aspect of Scapy. So we started in December with a little bit more than 50% of coverage. And as of today, I think the number is 77%. So it takes time, but one step after another, we're able to make Scapy better by writing this test and fixing the bugs. Also, we have some discussion to make the code, let's say, PEP 8 compliant. Scapy code, legacy code, is kind of unique in its coding style. Some people say it's ugly and it should not exist. So we are thinking of moving the code to, let's say, a cleaner syntax. But for us, the main question is who can do it, and is it possible to do it without breaking the history? Something we don't want to have is a single commit that will break the history. For example, if you use git blame, you won't be able to know who wrote that piece of code in the first place. It's difficult to, let's say, lint everything and preserving the history. So we don't know how to do that yet, but it's something we have in mind for a long time. Especially because even for us, the code from time to time is not nice. Also, like due to historical reason, the codes and some code and some function are never used or never tested. So again, that's something we want to change. And if I have time this year, I think I will invest my time in something called Scapy 3, which is a proof of concept by Philippe Biondi. This one you can find it on Bitbucket. It was designed as a pure rewrite of Scapy 2, and the goal was to say, okay, if we need to invest time in Python 3 support, it's better to write Scapy again. So Philippe did that, so I need to have a look at this code and see what we can do, either like pushing it at a new project or pushing ideas from Scapy 3, the proof of concept, into Scapy 2. Also, I would like to work on speed improvements in order to try to make Scapy a little bit faster. As of today, my main goal is to write more unit tests and to get more code coverage.
And are there any other topics that you think we should cover before we start to close out the show?
No, I think we're okay.
Scapy is definitely a very interesting project with a lot of capabilities, so I highly recommend that people download it, play with it, read through the documentation, because there's a lot there that we weren't able to cover today. So for people who want to follow you and get in touch, I'll have you add your preferred contact information to the show notes. And with that, I'll bring us to the picks. And my pick today is a music artist called Buckethead. And he gets that name because he at least used to, and I believe still does, perform wearing a mask and a Kentucky Fried Chicken bucket on his head. But he is an incredible guitarist. He has a lot of really interesting styles and has played with some other interesting musicians as well. So I definitely recommend checking him out. Most of his stuff is purely instrumental, but he occasionally has vocalists appear on his albums as well. So definitely recommend that. And do you have any picks for us today, Guillaume?
Yeah, it will be related to development. So yeah, Rust will be my pick today. So last weeks I tried to play with Rust as a new way to implement Scapy core. So far there is no much success, but it's always fun to play with a new language such as Rust because it's like give you new ideas. Like for example, gave me new ideas for like changing stuff in Scapy or writing stuff differently. So my pick will be Rust. Yeah, let's say I will tell people it's always good to start with a new language because it's fun.
Well, I really appreciate you taking the time out of your day to join me and tell us all more about the history and implementation of Scapy. It's definitely a project that I plan to experiment with some more and see if I can find any other use cases for it. So I hope you enjoy the rest of your day.
Yeah, thank you.